current and voltages of the circuit shown. Construct a phasor diagram. Have y'all done phasor diagrams? I don't think I've ever seen him test on that, so we're not going to do the phasor diagram. So we won't do that. But we will find all those phasors. All right, so first thing we need to do is look at this and convert everything to the phasor domain. So what is omega? Yeah, so it's the angular frequency. And in this particular problem, how do we know what the frequency is?
It's the frequency times 2 pi.
Well, okay, so the frequency is the angular, the angular frequency is 2 pi times the frequency, but I'm not given, I don't have the frequency is not given. How do I find it in this problem? I need it.
Divide 500 by 2 pi.
Actually, it's just going to be 500. This one is correct. So the number that's in there is correct. So omega is 500. Now, what's the phasor for the voltage? Yep, 10 at 0 degrees. There's no phase. The phase would be if it was in degrees here. So like if I had 10 cosine 500t, right, if I had minus 35 degrees, that would equal 10 angle negative 35 degrees. All right, how do I cast the resistor into the phasor domain? It's the easiest one. Resistors are always your friend. Resistors are just the same. So it's 100 ohms.
Is this like just finding the impedances pretty much?
Yeah. Yeah. And then how do I do the inductor?
Isn't it like a formula for that?
Yeah, it's on the top of your handout. If you look, I have under Z for the impedances. If you look at L, it says J omega L. So this is J omega L.
So, what?
So J times 500 times 0.2. 0.2 is 1/5, so this should be J 100. All right, so what is my total impedance for this circuit? 100 plus J 100. And the units for impedance is still ohms. And I can still do V equals IR. So I can still say that 10 angle 0 equals I times, well here it'd be IZ, 100 plus J 100. So I have a mixture here. I have phasors for the voltage, and I have it in rectangular for the impedance. And I can either change the voltage to rectangular, or I can change the rectangular to a phasor. And usually I go with rectangular just because I'm more familiar with that, but this one is really easy. If the resistive part and the inductive part are the same, so it's 100 and 100, that means it's a 45, you were going to tell me?
No, wouldn't we do it like change the resistor or the impedance into phasor because we're going to have to divide to find the current?
Yes, but you can divide with rectangular or phasors. Yeah, it's easier to divide with phasors, but it's easier to add and subtract with rectangular. But with a calculator that does complex, it doesn't matter. It can do both of them, and you can mix them up. So I don't really have to change this if I don't want to. I'm going to just to show you how. So to change this to a phasor, this would be, the magnitude would be 100 squared plus 100 squared, and the angle would be the inverse tangent of 100 over 100. And so that magnitude is 10 times the square root of 2. And what is the inverse tangent of 1? 45 degrees. And then 10 square root 2 is I knew that, 14.14. And so this is 10 angle 0 over 14.14 angle 45 degrees equals I. Now, to do this completely by hand, you do 10 divided by 14.14, and the angle would be 0 minus 45 degrees. So 10 divided by 14.14 is 0.707. Angle negative 45 degrees equals I. Now, just to show you, I could have done this. So 10, well, I usually use fractions just to make sure I have everything in the right place. I don't have to put angle 0 because that's the same as just 10, but I can. Over 100 plus J100 equals, and then convert that to phasor, and then get the approximate, it was square root of 2 over 20. .0707. Oh, I forgot my 0. Did the other one have a 0? Did I do something wrong? They should be the same. Square root of 100 squared plus 100 squared should be 2 times 100 squared. Oh, right. Thank you. Decimal in the wrong place. Yep, 141. Thank you. So it should be a 0 there. Thank you. And this is going to be in amps. And then it asks us also for the voltage across the resistor and the voltage across the inductor. And so to get the voltage across the resistor, I take the current, which was 0.0707 angle negative 45. And multiply that times 100. And I get 7.07 angle negative 45.
Solve for VS.
I'm solving for VR. That would be volts. And then to solve for VL, I'll take J omega L, which was J100 times
Is that divided by 100?
what is divided by 100?
VR. That's saying divided.
No, that's times. Times my current, and my current was 0.0707 angle negative 45. Now J100 as a phasor, J means that it's going exactly at 90 degrees up, minus J is 90 degrees down or minus 90 degrees. So this is 100 angle negative 90 degrees, 0.0707 angle negative 45. So that would be 7.07 angle negative 135 degrees.
That's just a smooth, the negative 90.
It is because in phasors, this is the real axis and this is the imaginary axis. And so if you have something that is just strictly J, it's on the imaginary axis and that has an angle of 90 degrees. And if it was negative J, it would go down and that would have an angle of negative 90 degrees. You could also do, if you wanted to, the inverse tangent of, well, it'd be the inverse tangent of, well, you can't because it's infinity. So if I did B over A, it'd be 100 over 0. But if you remember, the inverse tangent of infinity is 90 degrees. So yeah, you just kind of, you want to be able to do that quickly. You want to just know that if you have just J, that's 90 degrees. You have just minus J, that's negative 90 degrees.
So why is that negative 90?
Because I make lots of mistakes like that. So I need y'all to like,
So it
thank
should
you.
be 90.
It should be 90, yes. And so this should be positive 45 degrees. Yeah, so you have to keep an eye on me, especially when I don't even have the right answers with me to check on. Okay, so let's see, was there anything else to do with this? VS. What is the relationship between VS and I? So what is the phase of VS?
Phase of VS.
Yeah,
Wouldn't it be 10 angle 0?
it's just angle 0. So the 0 is the phase.
Oh.
That's the phase. And the phase of the current is negative 45 degrees. Have y'all talked about leading and lagging?
Yeah.
Okay. So is the current leading or lagging?
I don't know.
Lag.
You told us some like weird acronym, not acronym, but like
Iceman?
phrase.
Eli the Iceman.
Eli the Iceman.
What did Eli the Iceman tell us?
I don't
Let me look at my notes.
It was like those voltage leads current is yeah, and it felt-
EMF leads current when? It doesn't always.
And it
Inductors
felt-
equal current lags and voltage. Capacitors current leads voltage.
Say that again.
Inductors current lags and voltage. capacitors, current leads to voltage.
Correct.
Ladder, no.
That is correct.
When was that?
You need a big name?
What's that? Oh, and you can also tell if you look if it's in rectangular, then if you have A plus JB, if the imaginary part is positive, that's going to be an inductor, and that lags. If you have A minus JB, that's going to be a capacitor, and it leads. If you had it in rectangular. Okay, any other questions?
So the phase for the voltage source is just 0?
Yes. So here we said in this one, this is an inductor, so the current lags the voltage. And when you have the angles, you can tell it lags, it's negative, it's behind. The angle is behind.
So how do we go from the phase of the inductor to 45 to negative 45? Just 'cause it's
That's the
high.
phase of the current.
Not talking about from up there, the inductor. The voltage over the inductor.
How did I go from here to the negative 45?
Yes.
Because when you divide, you subtract the angles. So this would be 0 minus 45 becomes negative 45.
Oh wait, no, I'm talking about like in the left side. Like the VL, under the VL.
VO.
Yeah, like, did you go from that to what was below that?
Oh. No. I didn't. I don't think I used this. I was just talking about the phase of the source and the phase of the current. And I was using the current over here. The current that we solved for before. To get this, for the phase of the source, that was just from the problem. The phase of the current we had solved for over here. I didn't use the VL and the VR. Any other questions?